Hello there. So this talk is actually a portmanteau, actually a reinterpretation of one that my manager did, Emanuele. Emanuele is a wonderful divulgator. People going around and talking about stuff. I'm pretty sure you might have encountered him already if you were snooping around in Italy or, so for example, recently PyData Berlin. And he originally made the talk, so most of it, like 99% of the credit goes to him. And he has a really fun way to start talking about ChatGPT, right? Because our work, my day-to-day job is in the same company as his, which is called Extreme. We do AI solution and consultancy, and we really do care about going around trying to explain people what AI is and what it means, right? And before ChatGPT came out, it was fairly sometimes tough, right, to give people an understanding of how relevant and everywhere AI was and is. We were going about like talking and say, okay, guys, right, use Instagram, right? You know that the recommender algorithm, there's an algorithm behind that builds like and suggests you the content afterwards that is tailored to you, and that's because that's an algorithm, right? Now it's just easy. It's much easier, right, to go around and say, where is AI? For example, how many of you have at least used once ChatGPT, right? Basically everybody, right? Rendering the introduction to this talk mostly useless. But there is another thing to say. You know what ChatGPT is? It's just an AI. It's the most popular product ever. And it's by far the product that took the least amount of time to get to 100 million users. And this is remarkable, but there's also, and we need to really like to get a feel for how persistent it will be, and it actually is in our lives. And it's going to even become even more and more, right? It's going to become more and more relevant and prevalent in our lives. We need to understand the three key pieces that make it work as such. So we're going to talk about, right, and to start understanding properly, we talk about these three key ideas: embeddings, transformers, and reinforcement learning for human feedback. And these elements will actually tell us how to be judgmental and encounter and deal with those claims. For example, if ChatGPT actually is a useful tool for us. Because these three articles tell three different stories about the same paper where it has a different conclusion. So everybody was telling us a different thing about it. But this technology is everywhere, and the point of this abstract of this paper is that the people using ChatGPT, like the people who are like on a higher skill level, they're just putting like in a more like ground down to earth point, was that they used it, and the way they were using it increased their productivity. Whereas the people on the lower end of the spectrum, with a lower level of skill, it didn't really help them, though it gave them the feeling and the idea they were better performers at their job. And this is what we're going to deal with as humanity, right, in the next years. So what we would really like to talk about today, in the next 18 minutes or so, is just to give you a presentation of these three core ideas, starting with embeddings, or in another way, how computer can learn and represent for themselves meaning. Meaning like semantic meaning. Because you see here, we do like animals a lot. We usually talk about beavers, but the time we're going about with seals, right? We all know that's a seal. And we know that this word matches to that thing in our head. That's the meaning of seal, the semantic meaning. But we know that AI models, and models in general, and machines only understand numbers. So how do we represent seal, the concept of seal, inside the machine, right? And this goes back to back in the very beginning of the 60s, where we were trying to basically just build dictionaries as arrays, extremely sparse arrays, where we had just seal. There was a vector that had like every element set as 0 except 1, which was the position in the alphabet where seal was. And then book was another vector where there was like a 1, so like a positive index, in a whole extremely sparse vector. So a vector that has so many zeros inside, right? But this was highly inefficient, and it is highly inefficient because there is a lot of, they call it sparsity. So like, imagine like if there are like, say, 300,000 words, maybe even less, let's say 30,000, that would be just enough to represent the whole dictionary of the words that we use. You just have something that is always flat, and then there's a point in there. So, and every word is unique in this dimension. So imagine that you explode this in a cube, right? You see that you have just one dot in this whole enormous representation, where information is only in that point, and the rest is just empty, right? And so this is an extremely inefficient representation of words in the space. But it has three main, and I really, this is like the technical problem. The real problem is something else, right? And we kind of know it, right? But I will get to that later, because there is still something you need to figure out. If you give this representation, how do you represent meaning in words? How do you build up the words, like the meaning of a whole sentence? Provided that even if this worked, how can we make sense of a word that said like a seal is on the ice, right? If we just represent it as a sequence of vectors, or these empty sparse vectors, we're going to make only so much out of it. And one of the key novelties in this sector was by this extremely renowned paper, which is called like word2vec. That was developed by some guys at Google. Like what ChatGPT came out of was basically 10 years of research by Google. Folks at OpenAI did a great part in the last bit, but like the real, down to earth, the most profound things that came up was from papers from Google. The first one being word2vec, which was a way to represent words in dense vectors. So not like sparse vector with 0 and 1, just 1, 1, but like as a vector of dense numeric, so like a series of weights, basically, numbers from 0 to 1, for example. And this is basically something that you might have seen fairly well around, more than once. So basically, with this neural network that was able to basically take a word and assign weights to it. And these, you see here that these are not like dense, sparse weights. They are dense weights. We say dense because every element has a number in it. And this makes it possible that if you take man and subtract woman, basically the numerical representation is something that gives like the idea of say a human being. So if you add king, the weights of king to this, you will obtain queen. Or actually, if you do it like one way around, you see here that basically we can reason about words numerically, like in a space, which was something that was extremely hard, numerically inefficient, and really hard to picture in our minds to do with sparse vectors. Now, basically, if you have like the same space, like the same number of dimensions in space, and every dimension has a weight, then you can start to realize that this distance between man and woman should kind of always be the same, approximately, right? Between every every pair of words where there are like the distinct between man and woman. So you should maybe teacher is not like a proper example here, but you see this was worked really well between king and queen. There is a series of outstanding YouTube videos by 3 Blue 1 Brown, Grant Sanderson, who also gave a wonderful commencement speech after the graduation of the students at Harvard this year. And it was also making another example. If you take the word embedding, so the vectors of Italy and Mussolini, and you subtract Germany, you will get the resulting point will be somewhat close to Hitler. Right? I mean, this is a bit creepy, but this gets you the idea that if we have these richer representation of numbers in space, we can start mapping words in the space and say that some words have a certain distance between each other. And this is how basically words are represented in the vocabulary of ChatGPT in the mind. Every word we use, actually a subpart of a word, which is called a vector token, but it doesn't really matter right now. It's just a series of numbers along a certain number of dimensions. The more dimensions, the richer this representation, because it's like a bigger fan of possibilities where you can capture these these shades, right, of meaning. And the more they are, but of course, like the more words they are, the more and the bigger number the dimension there is, like the bigger this vocabulary, and the more expensive the model. And this is why these models are becoming bigger and bigger and bigger, right? Actually, they were for a little while, because you need to capture all of the richness in our vocabulary. And this is what allows us not only to capture the words like, not only like lexically, being a part of a vocabulary, but like semantically, with all of the wealth of meaning that we are used to give them. And this is like a practical explanation, and forget about the numbers, this is just like for mathematical purposes, but the point is that the meaning of this word here is given by the words that stand a lot like around it. The way this word-to-vec model works is, and how it produces these numbers, is by ingesting a huge quantity of raw text and trying to, given a word and its context, to basically guess the weight, the position, and progressively adjust the position in this huge space of every word. And this sounds pretty much abstract to you, but I think that the next image will actually be of help to you. This is how this magical model learn how to basically put the words in the right vector space. Basically, what we do when we train a word-to-vec model, and the first step that we train like the model that makes up ChatGPT, is in this way, like what we used to do to learn, I don't know, il congiuntivo, like verbs, or learning words in English, or even more sophisticated temporal verbs or conjugation of the verbs in our own language. Basically, we take all of the text in the internet that it's either public or they forget that they used it, or they don't know they used it, and they take it and they just hide some parts of the text and make the model guess the word. And by guessing the correct word, because because if we say remove small here, we know what's the true here, the true value here, the model starts to adjust its so-called weights, which are basically the numbers that we have in these vectors associated with each word, and it starts to basically just guess the right word given a context. So, and this thing is called masked learning or masked language modeling. But this is just to give you an idea, like how closer to our intuition of how we make basically people learn, like some concept in Italy, we were able to model it for machines to start building a representation of them in mind, using a whole lot of text, unstructured raw text that we have in mind. And they're all available, and it's really easy to use because we already have all the text from, say, Wikipedia, and we can just hide a bunch of words somewhere and have the model figure out which are the words. And we can even do it even better and better, giving them what's called negative examples, so words that they shouldn't be using at all, that do not appear together. And by this kind of training, given a lot of time and compute resources, you get this. And this is outstanding, but the theory behind it, and I'll give you a couple of references, it's just very easy to grasp, I would argue. Because this is basically a really kind of procedure that we were able to codify, like program, and have a system learn it. So we were able to extract from our own experience and put it basically in a machine and inform it. Just to keep in mind, the model isn't learning these things on its own. We actively model this, right? We were able to simplify or extract an algorithm that captured some of the shades of the way we learn and put it in there. And this is basically the same way that models learn how to use images as well, because they hide pieces of the image and they have the model reconstruct them. But this leaves us with another error: synonyms. We know that a seal put a seal doesn't always mean the same thing, right? And using this richer context and way of learning from the neighboring words, we can also build a representation using transformers of synonyms. Because the problem with this approach here is that seal here, with this number, can both be the animal and the physical stamp, right? And when we do this rich representation, it can also be the same, because man here may not be an example, but seal here would have the same representation with both. And that is the novelty that was from the very, very famous paper of this Bert, but mostly before, like the transformer, like the ever-famous paper, Attention is All You Need. What this paper did was simply, and get me there we go, use the context, and from all of the context that there was before, just select the most important words out of it. And I think there is a more important representation here, where basically your query is basically all the text that comes before, and the keys are all a bunch of values, basically the key and a value, are used to establish which one is the output. This is a bit complex, so let me just rephrase it. the idea behind attention mechanism, which made possible BERT, which is the model that is used on Google search. When you type something and it suggests you, maybe you meant something else. That's because this model basically guesses the right word and says, okay, maybe you weren't really looking for this one. Or it is the model that is used to give you most pertinent results because it learns how to rank stuff, because it has this comprehension of the context that is given by something that is a bit more sophisticated than this, but it has like the output is just the same, but the way it combines this value is a bit more richer than that. And the idea is just that when we are trying to predict the next word, when you say ChatGPT, like, and give it an input of a sequence, when it needs to predict this word, it uses every word that comes before it, and let's just say it has saved somewhere in basically its memory a series of combination of weights of the words that came before, and it multiplies them to fetch the key value, the value afterwards. And in this rich representation, basically, we see that when we try to predict the next word, different words have a different weight, which means that, for example, suppose this sentence is, can you please tell me what, I don't know, or tell me a story that of a fairy in a garden. And then, and this is the word, basically it is exploded in all of its components, and the model has learned to, not only to produce these embeddings, these dense representation of words, but to associate multiple embeddings, right, multiple vectors to each of those words that make up the query that you make, and can selectively use those to pick up the most important pieces of the, like, most important values, most important elements of the context. So, to put it like in another way, it's using the elements of the word, and it has learned that given a certain word, some other words in the context that came before are much more important than others. And if you think about that, that's basically what we do, right? Because now you don't really need to remember every single piece of word that I said. You just remember the key values. You remember the word embedding. You remember the word mass modeling. You might remember dense vector. And we were able to put into a machine this kind of logic of, given a certain word, recognize which other words are more important than the others, and use those to make a prediction of what comes next. This model was originally actually used for translation. And if you think about it, it's really intuitive, right? Because if you're trying to translate the European Union in English or in French, l'Union Européenne, like, the model needs to know the English word, and it was the European Union. So when it needs to translate l'Union, it will know that the next word is Européen, like European, so it will be more likely to output a word that has more pertinence to the context that there is when you were trained that. This is a bit more abstract. This is by far the toughest topic. But the key idea is the model was not only trained to learn representations of the word in a numerical space where you can basically do arithmetic operations, but only to rank, to give a set of weights where you give basically the importance of a word in given a certain context. So basically when a new word comes, only the weights that are most important for that word are picked, so that it can use those weights to make the new informed prediction about what comes next that is more relevant to the context that came before. And the last bit is how GPT came to be. What I'm telling you right now is this huge bit. And this is something that takes quite a long time. For example, something like in rounds of months, possibly. Something that takes a huge quantity of text, all of the data there is on the internet, even what they tell you they didn't use, or what they can't tell you that they used, or they don't remember how they was trained to. It's raw text, poor quality, the worst thing that happens, or the worst thing that you can read on the internet. Maybe somebody of you heard of Minerva, like an LLM that was trained in Italy, from the La Sapienza University? And then a couple of articles were starting to pop out. But this model speaks like Generale Vannacci, so it has like racist content and slurs. But that's because like the raw content it was trained on was just everything that it saw that we produced and put out on the internet. And it learns like we used to learn past tenses in school. And this takes months and lots of GPUs, lots and lots of compute. And it takes like, orders of tens of millions of dollars, but it's getting lower and lower because we're getting better at it. And this produces a base model, which is something that it is unable to be used as a product, as ChatGPT. So we do 2 more rounds of training with much less data, of bigger and bigger quality, of higher and higher quality. The first one being, it's called supervised fine-tuning, where you see here we went from trillions, so thousands of billions of words, to just maybe 1 million of words in total, maybe 10 million. So like 3 orders of magnitude less, or even more, 5 or 6 sometimes, to make the model learn how to speak in a helpful assistant. We call it like in a instruction format. So how do I do this? And the model learns how to respond to the structure of question and answers. And then by the end of this training, that takes like a fraction of what it used to be doing, like from months to days. It learns how to properly answer in a format that it is useful as an assistant. But then it doesn't really know how to give the most appropriate answer, right? That's why we see like maybe producing answers that don't really matter, or they use irrelevant context. So they suggest you to drink or to use glue on top of your pizza to make it like better, right? There's something that really happened in the past few days if you were on Reddit. The last step is another extremely round of, and the thing that we know the least amount of, which is called reinforcement learning from human feedback, which is basically still an undocumented procedure that can be undergone in different ways. But the most time-consuming and the original one that was used, very likely used by GPT, like by OpenAI, is to have people writing questions and answers, like producing a bunch of answers and telling which one was the best answers out of all of them. And train a model to rank the most appropriate answers, and then do another round of training along the same order of magnitude as the first the second one, the instruction fine-tuning, so that the model can learn not only to give an answer in an appropriate format, but the best answer given a set of possible ones. So not only the model has learned how to behave like an assistant, but to behave like an helpful assistant, somebody that can actually give you proper recommendations. And basically, this is all there is, right, to ChatGPT. 3 phases: learning using embeddings and transformer architecture to give context, learn context, and be able to build a semantic representation. A second step, which is everything that you need to make it behave like we are doing, answering questions or conversing, basically, like chatting. And finally, a step about which we don't really know much right now. There are some alternatives and some research has been done, but basically this is like the step that we know the least amount of, because they're a bit more secretive about it. Even like the Llama papers, like the open source models, don't really do a lot of good, like in explaining us how they did it. Like the code that we don't know it, like you know how they produce this data. But basically involves using a model that learns how to rank the answers in order like of quality, and then progressively have the model, the final model, which is the reinforcement learning model, basically ChatGPT, almost ChatGPT, right? Be able to produce helpful answers to you. And this is all there is to build a product like that. So my name was Luca. I am an AI engineer in Extreme day by day. I do this kind of things every day, building safe, helpful AI solutions using generative AI. But I'm also an open source maintainer of a time series forecasting library. You can reach out to me through LinkedIn. I would really love to get your feedback, especially about this improvised talk, and if it was effective enough for you to understand the content. So please feel free to reach out and tell me anything you had in mind about this talk and how I delivered it, because I would really cherish for you to have all the tools that you need to deal with these novelties and with this kind of revolution or hype anyway, and have the proper tools to see what we're coming at us and how to handle and see what's behind the mist and what is just hype and what's real value for us. Thank you very much.
Unfortunately, we do not have time for question, but I really, really want to say thank you for this improvisation. So please, another huge applause for Luca.
Thank you.
Thank you again.